You all to be aware that that pink line is both x, y, and little w. Does everybody understand this? If you understand that, then you can tell me what are the two names that I could give to the purple line. X, W, or little y. What are the two names I can give to the green line? WY or lil x. Everybody knows this, yes? Good. What side is opposite angle WXY? WY. B. Everybody understands that opposite means across the triangle. Yes? Sweet. What are the sides adjacent to P? This is a little tricky. Damaris? That's why this gets tricky. There is what adjacent means in English, and then there is what adjacent means in trigonometry. Darn it. In English, first of all, where is angle P? Where's angle P? It's the yellow one. In English, there are two sides adjacent to angle P. But in trigonometry, there is only one side adjacent to angle P. Is this a trigonometry question or is this an English question? Trigonometry question. So I must only care about the side that is adjacent in a trigonometrical sense. What side is that? PQ. Only. All right. Why? Because PR, although it is technically adjacent, it is the hypotenuse in a trigonometrical sense. Everybody good? Sweet. And number 4. What is the sine of x as a ratio of this? Sine equals what? Opposite over hypotenuse. Since I have no numbers there, I have to use the letters. What is opposite to x? Y, Z. What is the hypotenuse? X, X, Y. And we usually write these in alphabetical order. Is that somewhere on there? Yes. E. Did everybody get 4 out of 4 on the first page? You needn't tell me if you didn't, but if you didn't, you should be thinking, oh darn, I'd better be asking some questions now. Everybody good? Spectacular. That is my favorite kind of spec, the tacular ones. I know it's not Thursday, but when does a doctor get angry? When he has no patience. What has 10 letters and starts with gas? Automobile. My wife bought a bag of Laffy Taffy when we drove to Seattle, and Laffy Taffy in America has little jokes on it. So on the whole drive, I was subject to a million of these little jokes. Those are the only two that I remember because the rest were bad. Imagine how bad they were if those two were the good ones. Then there was the time-honored traditional one. Why didn't the skeleton climb the mountain? Didn't have the guts. I can't remember any of the others now. But have no fear, my wife is addicted to Laffy Taffy. She will have eaten the whole bag by the time I go home tonight. She will have a bunch more to tell me. She is also very bad at throwing away wrappers of individual candy. She makes a little pile of them. Kind of like, I don't know, back in the old days when cave people would eat a mammoth and then leave the bones. My whole family leaves their wrappers. It's very frustrating to me. Anyway, yes, Burke?
Do you still have the cookie cutter?
Do I have...
The lukewarm cookie cutter?
The what cookie cutter?
The Star Wars cookie cutter.
Oh, yeah. Of course. I have all my Star Wars cookie cutters. I have an X-Wing fighter and a Millennium Falcon cookie cutters. And I have the big bad thing. I don't remember. I think it's a Wampa from Empire Strikes Back. And I can't remember the other ones I have.
Well, I just remember you bought one and there's a lukewarm jokes on it.
Yeah, it's what is something about a Wampa? When is the best time to eat a Wampa cookies? Because I don't remember.
It was a good joke.
It was a good joke. All right. What is the cos of theta? 4/5. Nice. Everybody knows why, correct? Because the cos of theta is adjacent over hypotenuse. I don't like that big, thick pen. In XYZ, what is the value of tan x? 12 over 5. But, Mr. Myers, tan theta is opposite over adjacent. There's nothing there. But there is something there because this is a right angle triangle. So that's the square root of 13 squared minus 5 squared, which is the square root of 144, which equals 12. The sine of what angle is 12/13? X. Because sine equals opposite over hypotenuse. So 12 is opposite to x. So it must, and the hypotenuse never changes. Is everybody good? Bueno. Which trig ratio can I use to find the hypotenuse? What can I use? Can I use cos of 20? Cos 20 would be adjacent and hypotenuse, so I can use cos 20. Darn it. I would like to reconnect, thank you. I cannot use tan because tan is O and A and I need a hypotenuse. So they're automatically out. I can't use 70 because I have two unknowns, y and hypotenuse. And I can't use sine of 20 because sine of 20 opposite and hypotenuse, two unknowns. Yeah? Yeah, sure. You betcha. Find a to the nearest tenth of a degree if the cos of a is 0.906. This is a calculator question. You cannot do this in your head. Damn. What is the answer?
25.0.
A. And you find that on your calculator by using the second function or shift cos button. Some of you have what I call a forward calculator. Some of you have a backwards calculator. You need to know how your machine works. You either push cos 40 equals, shift cos 40 equals, or 40 cos 40, not 40, shift cos 0.906, or you push 0.906 shift cos. You have to know how your machine works. Damaris.
That's also cos -1, correct?
Yes. Shift cos will show up on your screen as cos -1. It is sometimes written on the calculator as cos -1. This finds angles. If you don't remember how to do it, you should be asking me right now. Also, if you didn't get 25, it is because your calculator is in the wrong mode. Somewhere on your gray calculator screen, you should see a little D or the word deg. If you do not see a D or a deg, you're in the wrong mode. If you are using one of these fancy calculators, you must push mode, and you must have the word degree highlighted to be able to do trig in this unit. Okay? Everybody is Gouda? Spectacular. 10. Which of those is correct? 7 over NP equals tan 25. E is correct. Now, this notation means find the measure of angle A. That is this angle right here. How will I find that measurement? I have an immediate option. I can use cosine. But I could also, some of you still do this. I don't know why. You will find the third side of the triangle so you can use tan. I do not understand that. I would just use cos. Since you need an angle, it is shift cos of 15 divided by 17. And that will get you an answer of, I don't remember, 49? 28. Yeah, yeah? Yeah, yeah, yeah. And number 12. It's the work that you did in number 10. What is it? C. Because tan 25 equals 7 over m. Since the number's on the bottom, it is 7 divided by tan 25. Now, a bunch of kids always say, oh, Mr. Myers, I don't remember how to do that. Why? Why is it divide? Why? Because of grade 5 algebra. tan 25 is just a number. If I gave you 3 equaled 7 over x, x would be 7/3. $13. What's the answer? D as in doorknob. Anybody need to ask about it? Once, twice, thrice. Sweet. Uh-oh. Word problems. Ugh. They make me quiver in my boots. The only thing scarier than a word problem is a fraction. So, should trig word problems ever scare you? Why? Why should they never scare you? Because you always need a triangle. Since this is grade 10 trig, you always need a 90-degree triangle. And now there's a ladder involved. Can ladders stand straight up and down? No. Does a ladder lying on the ground help you in any way? No. Where's the only place the ladder can go? There. What did I just make? A triangle. The ladder is 6 meters. 6. The angle to the ground is 70. What equation can be used to find the height up here? Sine 70 equals opposite the height over 6. C. How would you solve it? 6 times sine 70 will get you the height. I didn't ask you to solve it, but I want to make sure that we're cool. And fitting, what do I know? I know that angle C is 45. If angle C is 45, automatically I know a bunch of stuff. What do I know? I know angle A is 45. And what do I know about C and A? They're the same. Excellent. Which means if this is 15, I know this, don't I? I could do it with Trig or with Pythagoras. Do I even need to? No, because I got 45 there, so I can solve it with either cos or sine. And what is the answer? 10.6. B as in boom! I can do trig in my sleep. Is everybody good with grade 10 trig? If you are not, what must you do? Ask when? Now or lunchtime? Everybody cool? All right. Let's move on, cabbages. Turn to page 150. Oh, I got breakfast at this restaurant in Seattle yesterday morning. It's a breakfast joint. You can order your breakfasts in 3 ways. You can get a small, which is 3 eggs. You can get the regular size, which is 6 eggs. Or you can get the jumbo, which is 12 eggs. Omelets. They make omelets. My wife and I shared a 6-egg omelet. It was awesome. You get all-you-can-eat hash browns, but weirdly, you only get 1 piece of toast. 6-egg omelet, you get 1 piece of toast. Which is okay, because I can't eat toast anyway. But it was so good. That TV show Man vs. Food went there, and the guy tried to eat the 12-egg omelet by himself. He could not do it. It's called Beth's Cafe. Beth's Cafe is wicked awesome. All right. Now, you people are very comfortable doing trig when you have a triangle, yes? Please observe, I now no longer have just a triangle, all right? Or do I? What are the 3 trig rules? What do we know sine theta is? This is not a trick question. What is sine theta? He waited patiently. We just did a whole page on it. What's sine theta? Opposite over hypotenuse. Yay. What? Son of a... What is cos theta? Adjacent over hypotenuse. What is tan theta? Opposite over adjacent. Now over here, I'm going to draw the grade 10 triangle. Did it?
Yeah, I can right now.
This lil c, this lil b, this lil a. And you know that sine b is b over c. Sine a is a over c. Cos b is a over c. Cos a is b over c. And tan... No, wait a minute. Let's put it over here. Tan b is a over b. And tan a is b over a. You know all of that from grade 10 at least. Right? Everyone agree? Yeah? Okay. Now, knowing what you know, if you add some numbers there, you could tell me all the angles in this triangle. Agreed? We all know that from the 10th grade, correct? I know. Oh, it's doing the pause thing again. It was doing that earlier. That's awesome. Disconnect all, because you're a piece of crap. Everything about you is a piece of crap. I hate you. I want you to die. I want to use a board. So anyway, ladies and gentlemen, everybody please read the first line by the funny little arrowhead under the coordinate grid I have drawn there. Just read that line. An angle is in standard position if its vertex is at the origin and its initial ray lies on the positive x-axis. There's a bunch of geometry and triggy words in there, yes? What are some of the words in there that are slightly problematic? Initial ray. What's a ray? Sadly, this has been removed from a lot of BC classrooms, so a lot of you don't actually know this. What does the word Ray mean? It is not some dude named Ray. What is it? It's a line that continues on in one direction. So, if I have a point and I draw a line from it, that's a ray. A line goes in both directions. A ray goes in one. Do I have an angle right now? No, I only have a ray. To get an angle, I must draw another ray from what point? From the point I started from. Everybody cool? Now I have an angle. This is the initial ray, because that's where I started from. If I drop me a protractor on there, that's how I use it, yes? I line the protractor up with the initial ray. This is what we call the terminal ray, because that's where the angle ends or terminates. This is the vertex. So, now that you have been reminded of what all those words mean, please draw me an acute angle that is in standard position. I'm seeing how many of you actually understand that vocabulary. Draw me an acute angle in standard position. If you don't know what acute means, you're not going to be able to draw this, but I'm going to define it in a minute for you. If you don't know how to do this, draw as much as you can to satisfy this first one. I will be drawing that line in red. To draw an angle, you need two lines. Right now, you all can draw at least one of them. I will wait a second while you do so. That should be long enough to draw a line. Where must my line start? At the origin. Where is the origin? At 0, 0, right there. If I'm going to be in standard position, that initial ray must lie where? Along the positive x-axis. Where is the x-axis? It is the horizontal part. Which of that is positive? The right. This is what you have drawn so far. All of you should have been able to draw that. Now, the other ray is called the terminal arm, which I'm going to draw in blue. I said I wanted it to be acute. What does that mean? Less than 90 degrees. So any line between here and here will work. Is everybody with me? And the angle that we care about is right there. That is theta. Is everybody good to there? Now, you will notice that this creates the triangles that we were used to building in Math 10. Right? Is everybody good? Okay. Now, this is new. Counterclockwise rotation. This is 0. This is counterclockwise, or in Britain, anti-clockwise. If I go that way, I have positive angles. So this is a positive angle that I have drawn. Everybody cool? Now I want for you to draw me, and I'm going to change colors to red. No, I've already used red. I've already used blue. Green. I want you to draw me an obtuse angle that is in standard position. So, will the red line change? The initial arm? No. Will the terminal arm change? Yes. Where will an obtuse terminal arm live? Bigger than 90, but less than 180. Is everybody cool? Yes? Now, the last thing you need to know is if I draw a line down here, this gray theta in here, is it positive or negative? Negative, but the value of this angle is also positive if I go that way. Is everybody good? Yeah? Okay. If this is 0, what's this? 90. What's this? 180. What's this? 270. Everybody cool with the background? All right, let's see. Prove it. Draw these 6 angles. Do not use a protractor. Sketch them. You may work together, of course. There is no rules about that. When you have done those 6, I want you to try these 3. All right. I am only going to draw the terminal arm, okay? Because what do we know? Every initial arm is on the x-axis, yes? So they're all the same. Where will my terminal arm go in A? There. Okay? What quadrant is that? That is quadrant 1. Where will B go? Out here, into quadrant 2. Where will C go? Down here, into quadrant 3. Where will D go? Where will D go? Quadrant 1. Steeper than this one. I don't need it properly measured, but I need you to be aware that it will have to be steeper than this in quadrant 1. Where does E go? Quadrant 4. Where does F go? Quadrant 2. Is everybody good? What is different with the extra 3 I asked you to do? They're negative. So rather than going this way, I got to go the other way. So where is quadrant? What quadrant is G going to be in? 4. Because I had to go 75 this way. Meaning this is 360 because it's also 0 and the end of the circle, isn't it? So what is this guy's value? It's not just negative 75, it's something else. leave it at that for now. Where is this guy going? Quadrant 3, in here. Where's this guy going? Quadrant 3, in here. Is everybody good? Yes? Everybody can navigate around this? Okay, turn the page over. Reference angles. Highlight that. We are going to use that word all the time. Given an angle in standard position, which we have just drawn 8, 9 of them, haven't we? We know what an angle in standard position looks like. The reference angle is the angle between the terminal arm and the nearest x-axis. Please underline, highlight, Mrs. Bad Crumble cloud around nearest. Okay? So, I'm going to ask you to give me 2 angles now. In red, what am I doing? Red is the standard position angle, and blue is the reference angle. Everybody ready? Draw me 65 degrees in the first one. Where would it be? In the first quadrant. How will I draw 65 degrees? Where would it be? Everybody agree? Good enough. Yeah, we're just sketching. Okay. So that is my standard angle. What's the reference angle? Also 65 degrees. Why, Burke?
The nearest x-axis is 65.
Because the nearest x-axis is still here. Everybody good? Great. In the second box, draw me 115. Where will that be? In the second quadrant, out here, right? Where does the reference angle live? Is the reference angle here or here? Here. What will it be? If this is 115, what's this? 65. Why? Because if I went all the way, what would I have? 180. But I did not go all the way. I stopped 65 degrees short. Everybody with me? Okay. Next one. 245 degrees. Where would that be? In the third quadrant. How far is that? 245. Where is the reference angle? In here. And what is it?
-25.
What is it, Louis? Negative 65? 65. because I'm still going clockwise. Right? The angle is 65. And finally, $295. Where's the reference angle? Right there. And how long is it? 65. Is everybody good? The reference angle is between the terminal and the nearest x-axis. You guys do these four. Go. So use the sample to draw 4 new ones. All right, where's the first one going? Right there. There's the standard. What's the reference? 15. Where's the second one going? Out here. There's the standard, 120. Where's the reference? Here. And how big is it? 60. Where's this one going? Third quadrant. That is 250. Where's the reference? And what is it?
20.
No. 70. Because it is between the terminal and the x-axis. Where's the third one going? All the way around to here. That's 350. And what's the reference? 10. Can everybody do it? Sweet. Now, take grade 9 knowledge, apply it to grade 11. Where is this point going to be? Where? Put point P on this graph. Where? First quadrant. 3 to the right, up 2. There's the angle, yes? Do that for all of them. No, that should have been red, sorry. Once you have drawn them, tell me where the reference angles are. Put a little R in the reference angles. Everybody good? Everybody has their R's in the right spot? Okay. You guys do page 152. I have not given you answers. Do that page.